Welcome back. So we are going to continue solving exponential equations. So we solved some logarithmic equations. So we obviously know how to solve some exponential equations as well. So something to point out is we always want to isolate the exponential expression. If possible, we want to rewrite our bases in terms of the same number. If not, rewrite it as a log or take the log of both sides. Okay, that's something that we can do, is taking the log of both sides. And that's kind of our last resort. If we can't write the bases in the terms of the same number, if we can't write it as a log, then we're going to take the log of both sides. And you'll see what I'm talking about here. Very similar to how we solved our logarithmic equation. So here we go. In example 1, I see that I have 3 raised to the x minus 1 equal to the square root of 3 raised to the x plus 1. I notice that on both sides of my equal sign, my bases are almost the same. I want to rewrite them as the same base, and I can do that because I know that the square root of 3 is really just 3 to the 1/2 power. So I can rewrite this as 3 to the x minus 1 equals 3 to the 1/2 power times that x plus 1 power. Remember, raising a power to a power, we multiply our powers. So it's really like I have 3 to the 1/2 raised to the x plus 1, but I can drop those parentheses because raising a power to a power means I just multiply. So now that I have the same bases, both sides have a base of 3, I can just set my exponents equal to each other. So I have this x minus 1 equaling the 1/2 of x plus 1. And I'm going to solve for x. So obviously I'm going to distribute my 1/2. So I get x minus 1 equals 1/2 x plus 1/2. And then I solve for x. Let me condense this really quickly. Okay, so subtracting and adding and dividing and all that fun stuff, I end up getting 1/2 x equaling 3 over 2. So dividing by 1/2, I get x to be 3. And plugging it back in would give me the correct answer. 3 raised to the 2nd power is the same thing as the square root of 3 being raised to the 4th power. All right, let's try it again. Example 2, I have 1 over 9 raised to the 2x power equaling 27 raised to the x plus 1 power. So immediately when I look at my two bases, I might be thinking to myself, there's no way that I can write them as the same base. We can, right? Something is special about the 1 over 9 and the 27. They both have a factor of 3 in common. So using 3 as my base, how would I write 1 over 9 using 3 as a base? Well, that's 3 raised to the negative 2 power, 1 over 3 squared, 3 to the negative 2. So this is really 3 to the negative 2 power still being raised to the 2x. And you know that whenever we raise a power to a power, we multiply. So this will turn into a 3 to the negative 4x power. And that's going to equal 27 is 3 cubed. So if I have 3 cubed raised to the x plus 1, then I know that's just 3 raised to the 3 times x plus 1. Or you can distribute that, which would be 3x plus 3. I'll do that in the next step. What I'm saying here is now that I have the same base, I can set my exponents equal to each other. So I have the negative 4x equaling the 3x plus 3. I distributed that 3, and all I need to do now is solve. I end up getting negative 7x equaling 3, so that means x is going to be a negative 3 over 7. And that's okay, because if I go back to plug it in, where are the x's in this equation? They're in the exponents. Exponents can be negative, so it's totally fine. Okay, so here we get into some examples where we need to move some things around before we rewrite or isolate or, whatever. In example 3, I need to move that 1 over. So I subtract 1 on both sides. So now I'm getting 2 to the x equals 14. Well, I can't solve that. 2 raised to some power doesn't equal 14, some whole number power. I don't know that off the top of my head. Now, if that would have been something like 2 to the x power equals 4, I know what that is. I know that x is going to be 2, right? But when I see 2 to the x power equals 14, I can't really solve that. So I'm going to rewrite it as a log. So this would be log base 2 of 14 equals x. Done. Final answer. That is an exact answer. You're more than welcome to put log base 2 of 14 in your calculator and get an approximate answer, a decimal answer, but I just want it in exact form here, okay? Only round or put into the calculator if the directions tell you to do that, okay? So let's try it again. In example 4, we see 2e to the x divided by 3 power minus 2 equals 4. You want to try to isolate that variable. So we are needing to get to that x. First thing I want to do is add the 2 over. So now I get 2e to the x over 3 equals 6. Second thing I want to do is divide by 2 on both sides. E to the x over 3 equals 3. Okay. Remember, e is a number. So I technically have some number raised to a power, and that's equaling 3. I obviously cannot solve this off the top of my head. So what I will do is I will rewrite this in logarithmic form. Because my base is e, I want to use the natural log. Okay, so this is going to be natural log base e, and I don't have to write that base of e because it's understood, of 3 equals x over 3. Last thing I need to do to get x by itself is get rid of that fraction. So all I need to do is multiply both sides by 3. So this is going to give me x equals 3 times the natural log of 3. Okay. In example 5, this is you're gonna see that last resort being taken into effect. Okay. I have 2 to the x equals 3 to the x minus 1. There's no way that I can rewrite those bases so that they have the same base. 2 and 3. There's no common factor other than 1, and there's no way that I can rewrite it as 1 to some power to get 2 or 1 to some power to get 3. So what do I need to do is I need to take the log of both sides. So remember it said take the log of both sides. Okay, so that's what I'm going to do. I'm going to take the log of the left, which means I have log of 2 to the x, and I'm going to take the log of the right, which means I have log of 3 to the x minus 1. Now I'm going to rewrite this applying my power rule. Okay, if my argument is being raised to a power, that power then becomes the coefficient of the log. So this is x log of 2 equaling x minus 1 log of 3. Notice I'm just taking the log. It has a base of 10. It has that common base, okay? There's one more thing that I can do to expand the right side. So I have x minus 1 times the log of 3. I need to undistribute that or distribute it however you're thinking about it, okay? So this is going to be x log of 2 equals x log of 3 minus 1, and I don't have to put that 1, log of 3. So imagine distributing that log to the x and to the negative 1. X times log 3, and then a negative 1 times the log of 3. So that's going to give me x log 3 minus that 1 log 3, okay? Now I want to solve for x. So I need to get everything with x on one side and everything else on the other. Okay, so for me, all I need to do is move that x on the right-hand side over to the left-hand side. So this is now going to be x log 2 minus x log 3 equaling a negative log 3. If I'm trying to solve for x, on the left-hand side, both of my terms have an x in it, so I need to take it out. I need to factor it out. So that's going to leave me with x log of 2 minus the log of 3 equaling negative log 3. How do I get x by itself? I divide by the log 2 minus the log 3. So I get x equals negative log 3 divided by log 2 minus log 3. Final answer. Looks overwhelming, but it's really not that bad. Okay, definitely going to take some getting used to. Definitely going to have to practice that one, and you'll see it on your practice, and you'll see it on the week review. Okay, so let's try it again. Because we have the same situation in example 6. I have 3 to the x plus 2 equals 7 to the x minus 1. There's no way that we can rewrite our bases so that they are the same base. There's no way to do that. So we are going to take the log of both sides. So I have the log of 3 to the x plus 2 power equaling log of 7 to the x minus 1. Apply your power property. X plus 2 times log of 3 equals x minus 1 times log of 7. Distribute. X log 3 plus 2 log 3 equals x log 7 minus 1 log 7. Okay, move everything with an x on one side and everything without an x to the other side. So that's going to end up getting us x log 3 minus x log 7 equaling a negative 2 log 3 minus the log of 7. And you know that you can change the order of the left or the right, however you kind of see it unfold. That's totally fine. On the left-hand side, both of my terms have an x, so I'm going to factor it out. X times the log of 3 minus the log of 7 equals negative 2 log 3 minus log 7. How do I get x by itself? Divide. So x is equal to negative 2 log 3 minus log 7 divided by log of 3 minus log of 7. Okay? Remember, this is something from way back when. You cannot cancel out. Let me change colors. You cannot do this. Okay, why? Because those two log terms are being added or subtracted to one another. You can only do that with multiplication and division. Okay, if I have like 3 plus 1 divided by 4 plus 1, I can't just do this and get, oh, that's 3 over 4. Because you know that 3 plus 1 is actually 4 and 4 plus 1 is actually 5. And 4 over 5 does not equal 3 over 4. Okay, you cannot do that with adding and subtracting. You can only do that with multiplying and dividing. Okay, so this is our final answer. Again, kind of messy, kind of long, but not that difficult. Really just using your basic math skills. Okay, and then we'll see something like example 7. And you might be thinking, oh my God, that looks intimidating. It might at first, but what I'm going to suggest here is that we are going to use that U substitution, or really any kind of substitution. You can use Y, you can use A, you can use Z, whatever you want. All right, so notice that I have an e to the x here, and then I have an e to the 2x. Well, e to the 2x is actually e to the x squared. And so if I rewrite using U substitution, let U equal e to the x, then that means I get U squared minus U minus 6 equals 0. This is a quadratic that we can factor, that we can solve. Okay, so I need factors of negative 6 that add up to negative 1. That's going to be a minus 3 and a plus 2. So that means U is going to equal 3, or U is going to equal negative 2. Well, what does U equal? Substitute. That means e to the x equals 3, or e to the x equals negative 2. Well, if I rewrite that, taking the natural log, because e is a number, right? And I don't know what that 2.718 or whatever it is, raised to the x power equals 3. I don't know how to solve for x with that, right? But what I can do is I can take the natural log of both sides. So natural log base of e of 3 is equal to x, or the natural log of negative 2 equals x. We have to check for extraneous solutions. Immediately, I know that this is not going to be a solution. Why? Because the argument is negative. So that means x is equal to the natural log of 3. And c'est tout fini.